Hello and welcome to this lesson on mortgages and loans. Alright, so what we're going to be doing in this lesson is we're going to be applying the decreasing annuity formula in order to solve some problems that deal with loans and mortgages. We will also see how a down payment works into these exercises as well. So, let's get some definitions out of the way. First of all, what is a loan? A loan is a financial agreement between two parties. The borrower is given some money with the understanding that the borrower will pay back that money and sometimes an additional fee called interest. Sometimes it takes a long time to pay back these loans, and several payments are made over a period of time. If those payments are the same amount and the time periods are the same, then the loan is a decreasing annuity. So now let's take a look at what a mortgage is. A mortgage is a loan for land, a house, or some other real estate property. And then what is a down payment? When you're purchasing some property like a car or a loan, many times the buyer will pay part of the price up front and then get a loan for the rest. That part of the price that the buyer pays for up front of the loan before getting the loan, that's called the down payment. Okay, so let's take a look at our decreasing annuity formula. So our decreasing annuity formula that we'll be using is going to be P, which is our present value, is equal to this large fraction. In the top we have 1 minus, open parentheses, 1 plus I, close parentheses, raised to the negative n exponent over I, and then that is times R, where P is the present value on the account, which in this case is going to be the present value of the loan. R is the value of the rent payment, that periodic payment, so that's going to be our loan payment. I is the interest rate per period. Now to calculate I is equal to the yearly interest rate, little r, divided by M, which is the number of times interest is compounded in 1 year. And then N, that is the number of times interest is compounded in the total number of times interest is compounded. So N is going to be M times T, where M is the number of times interest is compounded in 1 year, and T is the number of years. So let's take a look at an example. So let's say that Mr. Moore wants to buy a house. He has $20,000 for a down payment and plans to make $800 monthly payments on the mortgage. He qualifies for a 20-year mortgage that makes 6% yearly interest compounded monthly. So we want to find the maximum value of a house that he can afford. So here we have some variables. R is the monthly payment, that's $800. This is going to be for 20 years, and the interest rate was 6%, so little r is 0.06. And the payments are monthly payments, so M is equal to 12. So we got to calculate I, that's that periodic interest rate. So calculating I, that gives us I is equal to R divided by M, and which is 0.06 divided by 12, that equals 0.005. N, that's M times T, so that's 12 times 20, which gives us 240. If we plug these values into our formula, that gives us P is equal to 1 minus, open parentheses, 1 plus 0.005, close parentheses, raised to an exponent of negative 240, and that is over 0.005. And then that's times 800. And then when we calculate that, that gives us $111,664.62. So that's the amount that we're going to borrow. If we then add the $20,000 for the down payment, that then gives us $131,664.62. So that is the amount that I can afford, the amount of money that I can afford to pay for a house, given that $800 payment and that interest rate and so forth. So if we know the monthly payment and the interest rates, then we can calculate the value of our loan. Now here we are calculating that big fraction. So trying to type in that large fraction into our calculator. There are many types of calculators depending on the type of calculator, and these are going to be based off of how your calculator deals with exponents. And this expression also has a negative sign up in that exponent, so we have to worry about that negative sign as well. Now for different calculators, some calculators will have a plus minus symbol on it, have a key with that plus minus symbol for the negative sign. Other calculators will have this parentheses dash close parentheses for the negative sign. So you got to make certain you use that for your negative and not use the subtraction button. So the subtraction and the negative, those are two different buttons. Make certain you use the correct one. Alright, so for the calculators where when you do exponent you get this little caret symbol, here's how we're going to type in that expression. So we're going to do left parentheses 1 minus left parentheses 1 plus 0.005, right parentheses, my caret symbol, and then this right here has to be our negative symbol. So negative 240, close parentheses, divided by, open parentheses, 0.005, close parentheses. And then when you calculate that, this gives us 139.580717. And then if you multiply that by the monthly payment of $800, that gave us the amount of that loan, which was $111,000 something. Alright. If we have the second type of calculator, where when you type in your exponent, it makes it look like an exponent, then with that type of calculator, we have to do the following. So we're going to do open parentheses 1 minus open parentheses 1 plus 0.005, our exponent button, followed by negative 240. Again, notice this is our negative symbol and not our subtraction symbol. At this point, our display should look something like this, where my exponent, the negative 240, is sort of written up high. To get out of the exponent, we're going to have to press the arrow to the right key to get back down on the main line. And then if we continue typing, we're going to do a right parentheses divided by 0.005. Pressing the equals button, that should give us our decimal, our 139.58077717. Then multiplying that by 800, that'll give us our value of our mortgage. Second example here. Let's say that Mr. Moore wants to buy a house valued at $175,000. I'm going to be making a $20,000 down payment, and he qualifies for a mortgage that makes 3% yearly interest compounded monthly. So we want to find out what our monthly payment is going to be. So identify our variables. Well, P, that's going to be the amount of the mortgage. Well, to find the amount of the mortgage, we got to take the down payment away from that $175,000. So $175,000 minus $20,000, that gives us $155,000. So we need a mortgage for that amount. Our yearly interest rate, little r, that is 0.03. This is going to be monthly, so M is equal to 12, and this is going to be for a period of 30 years. T is equal to 30. So, calculating my I is equal to R divided by M, so that's 0.03 divided by 12, which is equal to 0.0025. N is equal to M times T, so that's going to be 12 times 30, which is 360. So if we plug these into our decreasing annuity formula, this gives us 155,000 is equal to 1 minus, open parentheses, 1 plus 0.0025, close parentheses, negative 360 exponent. And all that is divided by 0.0025, and then times R. So if we calculate that lengthy fraction, that gives us 237.1893815. So updating our equation, we get 155,000 is equal to 237.1893815 times R. Divide both sides by the coefficient of R, the 237 decimal point, and then our lengthy decimal. So dividing both sides of our equation by that gives us 653.49 is equal to R. Or also you could say R is equal to 653.49. Alright, so how do we type in that lengthy fraction? I'm typing in that lengthy fraction. So again, notice we have to worry about our negative button. And we also have to worry about how our calculator does exponents. So for the type of calculator that when you type in exponents, it gives you this caret symbol. Then it's going to be left parentheses 1 minus, left parentheses 1 plus 0.0025, right parentheses, exponent, negative symbol, 360, right parentheses, divided by, left parentheses, 0.0025, right parentheses. And then when we calculate that, that gives us 237.1893815. So that's the same as this thing up here. Alright, the second type of calculator, again, this is the type where when you type in your exponent, it actually looks like an exponent. So typing this in, left parentheses 1 minus, left parentheses 1 plus 0.0025, exponent button followed by negative 360, which will look like this. And then push your arrow to the right key to get out of your exponent, and then right parentheses divided by 0.0025. Then press our equal button and we get our lengthy decimal. Alright, let's take a look at another example. Alright, so Mr. Moore wants to buy a house. He will make a down payment of $20,000 and get a mortgage for $111,664.62. You will make monthly payments of $800 on a 6% yearly interest rate mortgage, compounded monthly for 20 years. And we want to find what is the total amount of money he will pay for this house. So what we're doing here is we're using the numbers from example 1, and we want to find out the total amount that he's going to pay for that house. Well, when we take a look at his payments, well, he's got an $800 payment. He's going to be making that payment 12 times a year for 20 years. So when we multiply that, that gives us $192,000. So that's the total amount of money that he's going to pay over the course of 20 years. If we add that to the amount of the down payment, $20,000, that means he's going to be paying a total of $212,000 for that house. Okay, so the next example here is, well, Mr. Moore wants to buy a house. He'll be making a down payment of $20,000 and get a mortgage for $111,000, $664.62. He's going to make $800 payments on a 6% yearly interest rate mortgage for 20 years. And we want to find out how much interest he will pay on the mortgage. So if you recall from example 1, I'm using the same numbers there, and example 3. From example 3, he paid something like $212,000 total for that house. Some of that $212,000 went to, well, some of it was this mortgage payment, some of it was this down payment, but the rest of it was interest payment. So let's take a look at this. So we want to try to find out how much he paid in interest. So the amount that he borrows for the mortgage is $111,664.62. The total amount of the payments to pay back the mortgage was $192,000. We did that in example 3. So he pays back this $111,000 plus an equal fee, which will give us the $192,000. So calculating that, so $111,664.62 plus the interest, which is which is equal to $192,000. So subtracting that $111,000 on both sides, and that tells us that over the course of 20 years, he's going to pay $80,335.58. So that's how much interest he's going to pay over the course of 20 years. Let's take a look at another example. So example 5, Mr. Moore buys a house. He makes $800 monthly payments on that mortgage, and it's a 6% yearly interest rate mortgage, compounded monthly. We want to know how much money does he owe when he has 8 years left on the mortgage. When there's 8 years left, how much does he still owe on that house? So we're going to have capital R is equal to 800, little r is equal to 0.06, m is equal to 12, and t is equal to 8. There's 8 years left on the mortgage. Calculating my I, that's little r divided by m, which gives us 0.06 divided by 12, or 0.005. N is equal to m times t, which is 12 times 8, which is going to be 96. So if I plug these values into my decreasing annuity formula, this gives me P is equal to 1 minus, open parentheses, 1 plus 0.005, close parentheses, exponent negative 96 divided by 0.005. And then all of that is times 800. And then when we calculate that, that gives us 60,876.17. So when Mr. Moore has 8 years, 96 payments left on his mortgage, the current balance, the payoff amount, is $60,876.17. All right, let's take a look at example 6. All right, so Mr. Moore is buying a house. This is kind of the same house I've been using for these examples. He is making $800 monthly payments on a mortgage that has 6% yearly interest compounded monthly. And we want to find out how much does he owe when he has 7 years left on the mortgage. So this is like the problem above, except we're looking at 7 years left on the mortgage. So my capital R is the same, my little r is the same, my m is the same. The only thing that changes is the t, which is 7. So little r divided by little m, that is still 0.004. N is m times t, 12 times 7, which is 84. So plugging those into our formula for decreasing annuity, this gives us P is equal to 1 minus, open parentheses, 1 plus 0.005, close parentheses, exponent negative 84. All that is over 0.05 and then times 800. So when I calculate that, that gives me $54,762.43. So when Mr. Moore has 7 years left, which is 84 payments, that's how much he owes on the house. Let's take a look at another example. So Mr. Moore is buying a house. This is the same house, making $800 monthly payments. When he has 8 years left on the mortgage, he owes $876.17. When he has 7 years left on the mortgage, he has $54,762.43 left on the mortgage. Well, we want to know how much of his yearly payments that year went to the interest. So his yearly payments, well, he paid $800 a month for 12 months. So 800 times 12, that is $9,600. That's the total amount that he paid that year on his mortgage. Now the balance on the mortgage dropped from $60,876.17 to $54,762.43. So if we subtract those, that means during that year he paid his mortgage down by $6,113.74. The rest of that $9,600 went to pay on the interest. So if we subtract those two numbers, then that means he paid $3,486.26 on his interest that year. Now the reason why that is of some interest is sometimes when you are preparing to pay your taxes, sometimes you might be able to deduct your interest payments from your taxes. So sometimes it might be important just to be able to calculate how much interest you paid during a year on a loan. Alright, now let's take a look at amortization. In the previous examples, we were looking at a monthly payment of $800. Part of those payments lowered the amount of the loan. The rest of them had to go to pay for interest. And amortization is a breakdown of the payments into how much a single payment goes to the interest and how much goes to the balance. So let's take a look at an example. Mr. Moore is buying a house. He is making $800 monthly payments on a mortgage. That makes 6% yearly interest compounded monthly. After 8 years, he owes $60,876.17 on the mortgage. Build the amortization for the next 3 payments. So we need to identify our variables. Capital R is 800, little r is 0.006, M is 12, T is 8. So my capital P is 60,876.17. To calculate I is equal to R divided by M, which is 0.06 divided by 12, and that's equal to 0.005. Remember that little I, that is the interest rate per period. This is the rate of interest that is being applied every month. So for the interest that accumulates during the next month, to calculate that, we have to do I times P. So 0.005 times my $60,000, so that's how much we currently owe on the loan. That gives us 304.38. So during that period, the interest that accumulates is going to be $304.38. So when we go to make our mortgage payment of $800, $304 is going to go to the interest, and then the rest of it goes to pay down the balance of the loan. So of that $400 payment, $304.38 goes to interest, $495.62 goes to pay down the balance of the loan. So that's going to drop the balance of the loan. The new balance of the loan is going to be $60,876.17 minus $495.62, which gives us $60,380.55. We're now basically going to repeat what we just saw above. We're just now going to be using this current balance, which is the $60,380.55. So I times P to find out how much interest accumulates during that next month. That is going to be 0.005 times 380.55, which gives us 301.90. So that's how much interest is going to accumulate during that next month. So of that second payment of $800, $301.90 goes to the interest, and the remainder, $498.10, that goes to pay down the balance. So after paying down that balance, well, we owed $60,380.55. Taking off the $498.10.10, that means for the third month our balance is going to be $59,882.54. And then we repeat that process again for the third month. We find out how much interest accumulates during that third month, so that's I times P, which is 0.005 times 59,882.45, and that gives us 299.41. So when that third payment is made of $800, 299.41, that's going to go to the interest, and the rest of it, 500.59, that goes to pay down the mortgage. So if we put that information into a table called an amortization table, it'll look something like this. This left-hand column, that's the unpaid balance. So whenever we go to calculate how much interest, it's based off the unpaid balance. Here's all of our payments, which are all $800 a piece. Here's the amount that goes to the interest, and here's the amount that goes to pay on the principal. All right. I want to thank you for watching this lesson. I'll see you next time.